Okay, in my ultimate benevolence, which one would you like to do in class?
Between what?
You have quick sort for an array, merge sort for an array. Actually, I'm just going to allow you those two. We're not doing the linked list version.
Merge sort, quick sort.
Cool.
Oh, yeah. I'm going to get you started on it at least.
Merge sort has 3 arrays in it, right?
Merge sort will have, on an array, it just has 2 arrays.
But then
Which
you
one?
have to make a third one for
Merge sort? No, you have your main array and then your temporary array, and that's all you need.
Which one do you think is more difficult to code?
Merge sort? They're all the same to me. The hardest one to code would be the quick sort and using a linked list, which I think I thought about one day and put no, and just moved on in life.
But I'm making you guys do it.
No, I didn't say no.
He
I said
said one would be significantly easier than the other. So if he thought about it and then said no way, let's just throw that one aside.
That would be disgusting. I don't even want to think about it. Oh. It's not that sadness.
Thinking about it, and it makes me sad.
This wouldn't be too bad.
I'm
You just said
gonna
merge.
say merge sort.
Merge sort. We got merge sort all the way. All right.
All right, class code. We'll do merge sort.
And with the merge sort, with quick sort, you don't have to like make a new unit out of it. With merge sort, you do
All right, so let's go ahead and start with some array. Give me some values.
12.
6.
1. 18. 54.
You know, guys, I'm glad y'all aren't negative, but those numbers do exist. They have feelings.
negative numbers? No, they
Yeah.
don't.
Negative numbers.
I put negative numbers in the same category as imaginary. Get out of that.
So do you not believe in subtraction?
Yes.
Well, I'm sorry, another one? All right.
-4.
-4, 9,000, and 23. We're done. Okay. So we want to call a function called merge sort on the array. And what's the length here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Perfect.
Beautiful. Oops. All right, I've been doing way too much Java coding, so that may not be correct whatsoever, especially since it's not returning anything. Hey, it compiled.
Like, how did that happen?
What just happened? All right, let's go ahead and print this out.
I've learned that compiling means nothing
Yeah.
anymore.
Oh, it compiled.
Every time I'm like, oh yes, and then I hit run, it's like, brrr. Oh dang it. It's very much false.
Oh, that makes me happy.
It makes me happy that you guys are struggling.
See out. Oh, see out is so terrible.
I keep telling myself if it compiles, like, that's something,
That's
right?
something.
At least I'm doing it.
All right, there we go. So we print out the values. All
Yeah.
right, merge sort. So you're going to call merge sort. Really, when you want to think about recursive algorithms like this, the main call is the merge sort setup, and then the recursive call is the actual recursive call. So here in merge sort, the first one, we're actually going to set up the recursive call. And this is why I wanted to do one of these in class, is because I wanted to help you with ways to work with recursion. When you want to do recursive solution, it's usually good to have your main one function, set it up, and then the recursive call afterwards. So, and I'll show you why that's important in a moment. For example, if I'm up here and we'll go void merge sort recursive call. Really, you're going to have the array, and then you're going to have you're going to have your array. Ooh, let's make sure we put the size. You want to have the start position of the where you're starting. The size of the first list you want to start, and then the size of the second list you want to start. So int start, and then int s length, int end, and int end length. Seems a little confusing, but unfortunately that's how it is. And actually, you may not understand why it's like that first, but if we want to set up the recursive call first, because we can't really recurse at this point, I guess you could a little. You could say if size is equal to 0. If size equals 1, then you return, right? Otherwise, what do we do? Let's see if I can, do I have the slides up? Slides are on a different window. What chapter was it again?
18.
18? Yeah. All right, divide the list into 2 sublists. How are we going to do that? Probably need to pick a middle, don't we? All right. We'll do size divided by 2. It's going to be the middle? All right, well, I'll call it middle position. All right, great. Merge sort the first sublist. All right. Actually, we can do this with just merge sort. We don't need a helper function. Oh, this is beautiful. So if we want to merge sort the first one, it's really just, we're going to pass in the array again, and then what's the size? Middle, yeah. All right. And now we want to merge sort the second sublist. And this is going to be beautiful. Where's the second sublist start?
Middle pause plus 1.
Yeah,
All right, how do I type that in here?
middle position plus array, middle position plus 1.
Middle, I'm sorry. Say it again?
You type array, then comma, middle position plus 1.
I think you're on the right track, but that's only going to start this is the beginning of the array.
Oh.
You want to sort the right half. How do we put that in?
So then you do the array position of middle plus 1?
Oh, no.
And let me make this clear because I think this is somewhat confusing. So it is array, but it's array.
It's pointing at the middle position
Right, so how do we do that?
with the arrow.
No, you do the brackets like plus 1. Or you increment the next position over, right? And what you're pointing at.
Ooh.
Oh, no.
We did this
array,
in the-
I got you. Array, brackets, middle position plus 1, and then the end, which is size.
So you're going to do middle position, and then, oh, you said plus 1? All right, but that would get the element at that position. We want to pass the whole array. We want to pass, actually, what are we passing? Let's take a step back. What is the first argument to this list?
We're getting an array.
It's what?
So get an array.
The first argument is not an array.
It's an integer.
It's not an integer.
Pointer.
It's a pointer to an integer. Right. It's a pointer to an integer array, correct. And it points which element does it point to?
The first element.
The first element of the array. So down here, we want to pass another pointer. That's why I just realized we don't need a helper function for this. Where's it going to point to?
It needs to point to the middle position, right?
Yes, so how do we do that?
Once you do array and then like a little arrow in the middle position.
So it's not an object, because that's what the array would do. There we go. What's that doing?
Go into the middle position. The thing. Right? Like,
Is it incrementing the array, the amount of elements, that's the middle position?
Increments the pointer, right?
Increments the pointer. How many times
Yeah,
does
that's
it
what I
increment the
mean.
pointer?
middle pause.
Yeah.
Yeah, so that's just, that's what I was trying to say earlier. Like, because we did like the lab. way back
Right.
when.
Yeah.
I couldn't know how to say it.
Going to make your life a lot easier if we can understand. Yeah. Okay. So we get the middle. We'll call in the left half. Call in the right half. We probably have an off by one error, but whatever. Actually, because I don't think it's necessarily the middle position plus one. It might be plus one, and it might not. We're going to leave it like this for now, and I guess we'll fix it later. Oops, wrong side. Merge the first sublist and the second sublist. Okay. How are we going to do that? So now we need to merge. All right, this is what I was talking about where you need a temporary variable. So let's, just to make this easy for us, int temp there we go. So we have a temp. All right, well, we need a int. That's going to be the start position. We'll call it start one position, which equals 0. And then actually the other one is middle position, which is up here. So we already have this. All right, great. We'll call it start two position just to make it clear what's going on. All right. Well, S1 position is less than middle pause, and S2 position is less than size. If, this is how we're merging, if the array sub S1 position is less than the array sub S2 position, then we'll put the temp, ooh, we forgot to put a position variable. Temp sub position equals array sub S1 position, and then we will, yeah. Okay, we're not going to be tricky. We increment position, and then we increment S1 position as well, right? Otherwise, if that's not the case, we're taking it from S2 instead. So that's going to grab as many elements as it can into the temporary until we're somewhere. Until one of them is less than position. So this is till one is less than. Another way to do this, if it's less, actually, it's less than position, but you could also check to see if S2 position is S2 position, think about this, is greater than or equal to size, or because if S2 position is greater than or equal to size, then you just need to pop everything in there and you're done. Another thing we need to take into account, what if S1 position is equal to size? Oh. It's less than size, and S1 position is strictly less than middle position. Oh. Logic. Silly logic. So if that's the case, that's what we want to do. Otherwise, if S2 is still legal, or S1 is still legal, it's less than middle position, and that position happens to be less than S2, then we're good. In other words, what we're saying is, if S2 is not a valid position, just go with S1. Otherwise, if S1 is still a valid position, and then that means that both S1 and S2 position are valid, then do the check.
I think you would need another close bracket in the if statement after middle position.
You're right.
Oh.
All right. So temporary will then have all the values in it. And to make our lives easier, we'll go for int I equals 0, I is less than size, I plus plus, array sub I equals temp sub I. And then we'll just copy it all over. Wow, I wonder how close we are. I think we're actually pretty close. Let's see if any of that worked out. No! Not at all. Which I'm not surprised. Not surprised.
Those negatives.
Oh yeah, we got the negative 104. Yeah, we got those in there. So we need to go and dissect what's going wrong. And I'm going to show you how to do that. A nice thing is making sure you have a print function. Yeah, I think I already have the code for this, and I don't want to type it again. And just make sure that that's still printing correctly. Nope, too few arguments. Yeah. Perfect. All right, now it's printing. So now we have a print function. The beauty of this is we can do something like before merge. Before doesn't have an E at the end of it anymore. Before merge, print it out, and then of course after merge, print it out. All right, boom. So let's see what's going up on top. Before the merge, here's the full list. After the merge,
It just makes 12-0.
yeah, I just made 12-0. That's not good. So what's going on if it has to do with our middle position here and how we're dividing it out?
That been bugging me ever since we made it,
Good. Why is this not right?
because,
What's 10 divided by 2? Okay. So the first one is 0 and the first 5 elements. Let's go and write these elements up on the board. What do we got? Let me erase all this. Four, 12, 6, 1. 4, 12, 6, 1.
18.
Thank you. 18, 55,
Negative 100. Negative 4.
4,
9,000.
9. So 10 divided by 2 is 5. So 0, 1, 2, 3, 4, 5. It's pointing to the 55. Okay. So that first position is actually going to go from 0 to 18, 4 to 18. And the next one, we'll start at 55 and go 1, 2, 3, 4, 5. So that was actually correct. That's good. But how about the next time? Let's say we're over here. We're just looking at this right here. What's 5 divided by 2? Oh, is the... Hey, look, my video's gone. I'm going to do this to make it clear it's integer division. What's 5 divided by 2? Not integer division. We ignore the remainder. It's truncated. All right, so we go 0, 1. So that's the first call. And then the next one is going to be 0, 6, so it'll just be these two. What have we left out? 18. Ooh, we need to fix that first. Okay. I'm going to show you how this is easy. If size mod 2 equals 1 equals 0, aka size is even, then we just call it regularly. Otherwise, we need to increment by 1. Right? Sure. Okay. Let's see if that does anything. Nope. Which I'm not surprised. All right. What's going to be the first thing that we're showing before merge and after merge? Well, you know what? Why don't we have the code print that out so we can actually see it? Before merge, size equals %d. Oops, this is not printf. Size is 2, so it's actually comparing the 4 and the 12. So it's just looking at these two guys. I'm on the wrong page. Here we go. All right, 2. Middle position, 2 divided by 2 is 1. And that's why when it calls these two guys, it's just going to return that they're sorted. So now we're going to have position 1 is 0, and then this one is middle position. So middle position at this time is 1, because 2 divided by 2 is 1. Position is, of course, 0. So is S1 less than 0? Yes. And is S2 less than size? Yes, because S1, oh, that's not a good while loop. That's our problem. Less than size, then we're going to go in. So this loop jumps out once one of the two variables goes past it. What do we really want to do?
So after one passes it, everything else becomes 0?
It's probably just grabbing random memory, whatever's in temp, and then pushing it over. Do y'all see what I'm talking about? This is not going through the whole thing. What's this while loop? How many times should this while loop actually iterate?
It should go through the whole size.
Whole size. So really, right? Assuming everything else matches up. Well, that made it easy.
Okay.
It's important to do large printouts and test cases. Figure out what's happening. Although it's interesting that we got this.
Yeah.
Oh, I know why.
What's it doing?
Hold on. I know why it's printing those fun, weird numbers. I shouldn't be printing 10, I should be printing size. Here we go. Oh, that makes far more sense. After merge, it's 4 and 12 because we're merging the 4 and the 12. Before merge, after merge, we're just merging the 1 and the 18. Notice that this one is just looking at this guy up here. Oh, that's interesting. Came up with.
And then 2 zeros.
That's because this print is probably, again, I put in temp and not 10 and not size because we need to make sure we're printing off the correct size. That's even better. Before merge, 412, after, before merge, 1 and 18, and then goes on down the list. Oh, it's beautiful. Now it's printing it out correctly. That looks like things are set up. Oh, great. Is that right? Yeah, that's right. Any questions?
You have to check and make sure it's null.
Could you hear the smile?
Yes. I know that's one of the test cases. It's always one of the test cases.
You know, I just.
You can get hundreds of my labs.
Huh?
It's null in general in every lab.
It's like if you just test for null, you get 10 points, right? All right. Okay, well, you gotta make sure your code's, I guess, resilient. All right, but really, any questions about this code? Yeah, great. We are finishing about 10 minutes ahead of time, so you've got, an hour and 10 minutes for lab time. I highly suggest you get started on it. You should at least start thinking about your project in addition to coming up with, or at least studying for your midterm. Do study for your midterm. There will, if you don't, you will run out of time. All right, and that's it for today.